All right, ladies and gentlemen, we're going to be looking at section 3. You can see here there's only 6 questions. I personally think that sections 3 and 4 are the hardest 2 sections out of this. Prior to recording this, I just sat down and worked through all the problems, and there are a few that I had to really sit there and think about. So if you felt really confident on 1 and 2, that's good. That means that it gives you a little bit of wiggle room when you get to maybe a section that has some more that start to kind of scratch your brain. These could be questions that you would see more on the adaptive path if you start to place really high. And then there's some that are still kind of those like quote unquote layup problems. So let's go ahead and work through these. Compare your answer as you listen to it. And obviously, if you have any questions, you can still reach out to me. I'm still here at school, but I just wanted to be able to have this resource for you guys if I'm not in your classroom. Okay. John has to type a 2,000 word business report, and he types at a rate of 40 words per minute. So it's asking us here to figure out the domain. So remember, the domain is our input. So what is the lowest amount of words that he's going to type, and then what's the biggest amount of words? Well, we know that you can do 40 words per minute. The most words we're going to have is 2,000. So if we think about 2,000 divided by 40, we end up with 50, which means that this is going to be the most amount of time it takes them. Obviously, the smallest amount of time would be 0, which isn't really possible, but it is part of the domain. So our answer is going to be B here because any of the inputs could be anywhere between 0 and 50 minutes. The answer is not smaller than 0. We're not talking about negative time here. That's not even a possibility. Doesn't make any sense. Can be more than 50 minutes because we've then gone over the word limit. All real numbers would mean that we could do any amount of minutes, negative minutes, positive minutes. You could say 1 billion minutes. Okay, you only have to go to 2,000 words. So honestly, even without doing the arithmetic of it, that's the only one that makes sense. A company sold a total of 150 adult tickets and child tickets to a fundraiser. I'm just going to use my markup tool here. So I know that the adult tickets plus the children's tickets, we have 150 of them. The company charges $10 for the adult tickets. So 10A plus 6C. It says that Y represents the total amount raised. So 10 times the amount raised for the 10 times however many tickets they sell for adults. So this represents the number of adult tickets and the number of children tickets, plus 6 times the number of adult tickets and children tickets 6 times the number of children tickets equals Y. The problem here is that we could easily write a system of equations if we knew this value, but we don't know that value. And they're telling us to write an equation to represent the total amount Y in dollars raised from the sale of tickets in terms of X, the number of adult tickets sold. So I know 10 goes with the number of adult tickets. Sorry, I'm trying to look for my paper. We don't know how many adult tickets are sold, but I could find that by saying 10 times 150 minus X. Write an equation to represent the total amount raised from the sale of the tickets in terms of X, the number of adult tickets sold. So 10 times 150 minus X plus 6 times X. So I'm going to call X. I'm just sitting here looking, and this is the way. Oh, I've got it backwards here. So this would be true if we were saying that X represented the children's tickets. But X doesn't represent the children's tickets. X represents the adult tickets. So what I'm actually going to want to write is 10 times the number of adult tickets plus 6 times 150 minus how many ever adult tickets there are, we don't know, equals the total cost. And that's what I'm going to end up typing in here. So I've got 10. I've got to go back and forth on which keyboard I'm using, so give me a second. We've got 10x, so 10 times the number of adult tickets plus 6 times there were 150 tickets sold total. So if I take 150 minus however many adult tickets there are, that's going to give me the value of children's tickets equals Y. And we don't know what that total cost is. So they don't want us to solve anything. We actually don't have enough information to solve. We're just going to set up the equation. Okay, the quadratic function f is defined as f of x equals negative x plus 2 squared plus 3. Consider the graph of y equals f of x in the xy plane. Before I do anything else, I'm going to go ahead and type this quadratic into my graphing calculator so I can use it for reference for whatever it is it's going to ask us to do. So I've got it there. Even if I close out of my calculator, I'll go back, it's there. State whether there's a possible transformation of f in the form of g of x equals f of x plus k, where k is a constant, for which the graph of y equals g of x will have no x-intercepts. So what they're essentially asking me here is this 3 at the end. Can I change the constant on the outside of this? So we know that the vertex is at negative 2, 3. So can I change the value that's on the y of the vertex to make it so that we don't have any x-intercepts? So when I look at this here, I see there's an intersection here and here. I am thinking if I can shift this up, I'm still going to have 2 x-intercepts. They don't want any. But if I shift it down, then I will not have any x-intercepts. So if I only shift it down 1, now I'm at plus 2, I'm still not high, I'm not low enough. Even if I go at 0, I have one solution. So if I change this to negative 1 or anything, if I subtract anything bigger than 3, because, you know, we were at plus 3. So even if I subtracted like 3.1, I'm going to get something which would be like negative 0.99 or negative 0.01. It will not have any solutions. I know that looks really close to having an intercept, but it's not. Okay, you can see that it's below. So this is the way we're going to work this. So for the first one, we're going to say the vertex, and this is really not anything that we can use the drawing box for. You could draw a picture of the graph if you wanted to and then show how it shifts, but I think our words are just going to be the most important thing here. The vertex of f of x is at negative 2, 3. This, let's say f of x has 2 x-intercepts. In order to remove both x-intercepts, we will need to shift the graph down. If we subtract anything greater than 3, it doesn't have spell check on here, from f of x, we will not have any x-intercepts. For example, f of x minus 4 does not have any x-intercepts. So that answers the first question. So if we take our original and we subtract anything greater than 3, because the vertex is at 3, so anything greater than 3 is going to shift it down below the x-axis. Let's go back here, and I want to reread this. If we subtract anything greater than 3 from f of x, we will not have any x-intercepts, because the vertex will then be below the x-axis. I think that helps it. So for example, f of x minus 4 does not have any x-intercepts because its vertex would be at negative 2, negative 1. Okay. So now we need to think about this next piece. The next piece, that's super important because it doesn't say like part A or part B. You've got to know that you got to answer both of them in here. State whether there's a possible transformation of f in the form of g of x equals f x plus k, where k is a constant for which your graph y equals g of x will have no x-intercepts. So essentially what they're asking us here is, let me pull up my graph, and I'm going to get back to that original plus 3. They're asking if I can change this 2 value to anything else, to change from, can I add or subtract anything from that 2 to get me, I'm going to move that there, to get me no x-intercepts. Remember that this value here inside the parentheses is just shifting my graph from left to right. If I shift the graph from left to right, it is not moving it up and down. When we did first part, moving it down made it no longer touch the x-axis at all. But moving it left and right will continue to have 2 x-intercepts. So no, there isn't a possible transformation. So we're going to say there is not a possible transformation of f in the form of g of x equals f x plus k. Oops. F x plus k, where k is a constant for which y equals g of x will have no x-intercepts. When we change k in this instance, it will only shift the graph left and right. It will continue to have, it will continue to always have 2 solutions or x-intercepts. The only way to eliminate the x-intercepts is to shift the graph up. Is to only to shifting the graph actually one to it is to shift the graph down. Like we did in part 1. Okay. So I told you guys there's going to be a lot with shifting of graphs and really understanding what's happening there. Okay. A system of inequalities, good thing we practiced the other day, is given where a and b are positive integers. So they already have a graph for you. Typically the way it's going to be is that you won't have to graph the inequalities, the system, but you're going to have to be able to know which one's which. So the first one says y is less than ax minus b. That's going to be, let me use my markup tool here. So this has a negative, ooh, what just happened there? Where's that at? This one has a negative y-intercept, so that means it's this graph. So this one is going with the first line, and it's telling me it's less than, so I know I'm shading this way. The other graph is going to have to be the other one, and it's saying that it's shading above, so the only point of intersection is going to be right here. And that's all they want you to do is just select it. Okay. For the sport utility vehicles with weights of 1.875 tons and 3.25 tons, compare the fuel economy modeled by the function to the actual fuel economy for each sport utility vehicle. So over there on the left, you had a table that's showing the actual weight and fuel economy for these SUVs. And then on the side, you have an equation that's modeling the relationship. So the modeling is a prediction. The actual is the table. So the first thing they want us to do is to compare for 1.875 tons. Let's say the actual this is going to come straight from the table, so 36.8 miles per gallon, and the modeled was, we need to use our graphing calculator, and the modeled is negative 10.139 times, we're trying to find it for 1.875 plus 49.993, and we end up getting around 31 miles per gallon. For 3.25, we can do the same thing here. The actual was 19.6 miles per gallon, and modeled was, go back to that graphing calculator. Nice thing is it saves it. So I just have to change this to 3.25, around 17 miles per gallon. To find the actual, I'm going to just explain where I got this from. To find the actual amount, I used the table. To find the modeled amount, I substituted in the weight for x in the equation to find the MPGs. So there's really nothing else to explain. It says show your worker, explain how you found it. So I explained how I found it. I'm just saying I plugged it in. I have the amount. Says exactly what it is. I know I've gotten my full points in part A. Part B, I'm going to be 100% honest with you guys. I looked at this one and I looked at this one and I was confused as to what it asked. I then pulled up the answer key and was like, okay, that makes a little bit more sense. I think there are a lot of answers they would pick and say that are correct here. I don't think it has to just be what the answer key said. So this says, what is a regression function that better models the relationship between the fuel economy F of W in miles per gallon and the weight W in tons for the 8 sport utility vehicles? Justify your answer. So one thing that we could talk about here in the drawing box, it might help. Oops. Yep, undo. I want to undo that. In my drawing box here, if I'm looking at, I have 36.8, and then I had 28.4, 26.7, 24.8. When I found both of those, the predicted amount, if I remember correctly, I'm going back up top, the predicted amount was less than the actual amount. So something right there tells me that something wasn't right with the slope of the line. Perhaps it's not slope, and I'll talk about that more in a second. When I look here, I see the first thing I thought was that they modeled it using a linear relationship here, and I thought maybe we could just change the slope. But then the more I looked at it, the more I realized that this is something that starts falling pretty quickly. So like when I looked from 36.8 to 28.4, it decreased by 8.4. But then 28.4 minus 26.7 is only 1.7. And then I have 26.7 minus 24.8. This is only going down 1.9. 24.8 minus 23. I'm using my other calculator just so you guys don't have to switch. I'm not going back and forth between the screens. So this definitely isn't linear, right? We're not consistently falling by the same amount. So which then it made me think that if we're talking about a vehicle, I was like, it's not really quadratic, because if you're thinking quadratic, then it's going to be that if you're thinking quadratic, you would have that the lower there's going to be cars that weigh really less that get really good miles per gallon. But then there would also be, if you're thinking about the quadratic and how it curves, right, it increases and then goes down, you would have a sweet spot for this perfect weight of a car gets this perfect miles per gallon. But then as the weight starts to increase, it goes down, which is true. The heavier a car is, the less mile per gallon you're going to get. But if it's quadratic, then you're also saying a really, really light car would also have horrible miles per gallon. So a quadratic, that curve of a parabola doesn't make sense here. Which makes sense is that you have something that starts off with really good MPGs as you have a lower weight car, and then it's just going to slowly decrease as your car gets heavier. It's not going to be something super linear. So with that being said, when we looked at this and we saw how it was decreasing by something that wasn't linear, I believe that this is an exponential decay model. Now, it asks for us to write a regression, or what is a regression function that better models it. I don't think we have to actually give a specific, like say this percentage, etc. But I do think we need to say that an exponential regression function would better model this situation. The model they gave was linear, and this situation does not move in a linear fashion. It is not consistently decreasing, by the same amount every time. It decreases by quite a bit initially, and then starts to slow down, meaning it is exponential decay. So when something starts to decay, it drops really quickly initially. Like let's think if I'm at 100 and I'm halving something, I'm going to go from 100 to 50 right away, 50 to 25. So the biggest drop is the 50 at the initial. Then it's only dropping by 25. Then it's only going to drop by 12 and a half. So you can see here, like when I'm looking at the table, it dropped by a decent amount. You do have some that, like this right here, kind of throws that into a little bit of a, not 100%, right? There is kind of a big drop there. But then when I go back to the other one, we kind of have this outlier of that weight of 3 tons. But for the most part, it's moving in an exponential manner. I will say that was probably one of the hardest questions we've seen on these practice tests. Hopefully I didn't ramble too much. And the last question for this section, identify the domain for each function. Select the boxes to identify each domain. So for the first one, we have y equals negative times the absolute value plus x. I can plug any number I want into an absolute value function. There's nothing saying that I can't plug in other kind of numbers. Now, the range of that is going to vary because I know that I can't get a negative output from that absolute value of x. The next one, y equals negative 2/3 times the square root of x minus 1. I know that's going to have to be all real numbers greater than or equal to 0. I cannot find the square root of a negative number. It does not exist. That is a no solution. So I cannot have any negative numbers that are put into this. Okay. In order to get a solution, I cannot put a negative into that radical. And y equals 2x squared. I can square negative and positive numbers. So all real numbers. Hopefully that helped. Hopefully I didn't ramble too much. I apologize if I did. It's really hard to explain this over a video. I'm sorry I'm not there in the classroom. I just thought that this might be the next best thing. But like I said, if you still have a question, please ask me. I will do my best to answer it. Remember, these questions are going to range in difficulty level. There's going to be some that we get that are super easy. There's going to be some that we get that are really tough and difficult, and we're just trying to get the most points that we can. So like, for example, the one with the sports utility vehicles, maybe we don't get the whole 4 points on that, but we know we got part A correct, and we know we explained to the best of our ability in the last one. So even 3 out of 4 would be great. All right, guys,